In addition to me being a NATE alumni, so I took an architectural technology course, I'm also a CSC CTR, which is basically a certified technical rep for an organization called Construction Specifications Canada. If you guys aren't familiar with it, I'll have a link at the end of my presentation. You should check it out for continuing your education. I know you're in the middle of it right now, but in the future, when you're, if you decide to work in the construction industry and decide to continue on and want some more networking opportunities and some more chances to kind of build credentials within the industry, CSC is a fantastic organization for that. And that's what that little icon is on my screen. I'll show you a little later. What else is there? Yeah, and I handle all the prairies and northern regions. So I work with students, I work with professionals, consultants, architects, contractors, installers, general contractors. I've been doing this for a number of years, probably a decade in this industry prior to my other experience in other industries. Let's put it that way. So if you guys want to, just throw me on speaker view. That way you'll see it. I'm not going to be sharing my screen, so if you can, just hit your speaker view. Hopefully it'll pop up and everything will make sense when I'm going along here. And I'll get right in here. So that's mini me here in the corner. That way you don't have to bounce between my head and what I'm showing you on the screen. Hopefully it's not too distracting. All right. So what you guys are going to discover when you're in this industry, in commercial in particular, commercial construction, you might already know this, but I'll illustrate anyways. Every consultant, expert, distributor is sort of a very specialized level of information. So I don't know everything about all facades, facades being a fancy word for siding or covering of an exterior wall, typically used in commercial construction. You know, your vinyl siding could be called a facade on your house if you want to, but typically architectural panels, that kind of stuff are considered facades for commercial. But to finish my earlier point, you're going to notice people have a very kind of specific set of knowledge. So your roofing contractor guy will know his roofing style. It might be built up roofing or metal roofing, and they'll be very specialized in that, and that's what they'll sell. And that's because there's so much information in construction. Being an expert at everything isn't very useful. Also, distributors like Engineered Assemblies hire people like me to become good at educating the market and industry, including students. As well as, you know, 40-year veterans who've never heard of this material before. And we tend to specialize. So I'm not going to cover everything. It's a long way of saying that. But what I am going to cover is a particular style of exterior facade system called rear ventilated rain screen. And the acronym for that is RVRS. So some of you might already know this. Maybe you took some courses on it. I'm not going to spend a ton of time other than just to make sure you got the basic principles behind it. I'm also going to spend a little bit of time talking about substructures. So that's what actually holds. So on your exterior, when you have an exterior siding, cladding, whatever you want to call it, facade panel, you need something to hold it up, right? There's got to be a substructure. So we're going to talk a bit about that. We're going to talk about some testing. There are some standards in Canada that you need to meet for commercial construction. There's not as many as you would think, but there are a few real critical ones. I'm going to talk about those today. And then I'll get into all the materials, some of the things you can play with as far as like looks and appearances and materials and kind of their benefits and their aesthetics, which are fairly important in architecture. All right, and I'll have a Q&A session at the end. If everything goes smoothly, we'll have that, and I'll let Jose open the mics for that when it comes. So when I talk about rear ventilated rain screen, it actually there's two word combinations. There's rain screen and rear ventilated, and one came before the other. Actually, rain screen in the history of wall construction is really old. It's been around since the 1100s in mostly Scandinavian countries. Basically, what they did is they took plank boards, old wood plank boards, and they put little gaps in between it to make sure that the panels, the wood boards themselves, didn't rot out by trapping moisture behind it. So what they discovered is if you just put some boards up and you put little gaps in it, you get a little use the boards as a screen as opposed to like a big cement block wall or a stone block wall. It would trap moisture in the wall and it would preserve it. So there's some really old buildings. You can look it up, Google it, images, rain screen, Norway. You can see some really old buildings. But the principles behind rain screen are fairly straightforward and fairly universal across the industry. Everybody agrees with this. Is your facade or your material acts as a primary barrier against wind and rain. Okay, it assumes that some moisture will make it past the barrier. I'll show you guys a slide on that a little later. And it incorporates a secondary collection cavity behind the facade. So in this little parapet sort of cutaway detail, this is where my cursor is kind of sliding up and down. That is, we assume moisture gets in there, so we design detailing around that. Okay, so that is rain screen. So any bricks or masonry construction, any system that has a cavity collection cavity behind it that assumes that moisture can get into it and has some way of weeping it out is considered rain screen. Rear ventilation is a little newer tweak to that concept. It's been around since the 1960s in Norway. It's 1963-ish, Canada started to promote it, sort of write papers on it as a wall assembly. And it actually adds an element of air circulation. So not only are we worried about water getting through the system, through the facade, and draining it out, having a kind of collection and drainage area, we're actually adding airflow. Okay, and in a very specific way that ventilates the back of the material. And when they started using that and started adopting that into construction, you started seeing a lot of other materials kind of evolve from that. So, and that's the stuff that I sell and many others do, which is lightweight facade materials, things that don't require a lot of heavy structure on the exterior, don't require a whole bunch of caulking and beads and stuff like that to seal it up. But typically have fairly thin materials on the facade, still strong but thin. And then the other thing that this system allows is you to put in exterior insulation, because the way you're already kind of doing these elements where you're doing a ventilated channel behind the facade, you're doing a rain screen water collection channel, it didn't take a real big leap to throw exterior insulation on it. And there are other papers on this. Insulated structure is what the term is in the industry. So you can have you insulate on the exterior, your structure becomes warm, basically, or cold, depending what you're trying to do. But you actually insulate the structure. So you get the innovation of outboard insulation for creating more efficient building was part of the rear ventilated rain screen family. It's not exclusive to those products, but it's certainly they help promote those. All right. I'm going to show you this little clip here. We're going to talk a bit about that in a second. But we're going to talk about what the kind of principles behind this is. So in this case, we have a wall assembly here. You see a rendering, an elevation up here. You see various sections. And behind that kind of stone gray looking material, the joints could be potentially open, right? They could be open, they could be partially flashed. But what's important to make it rain screen is to have this uninterrupted vertical air channel. So I'm going to show you guys what that's made out of in a second. But that's the premise. So even a small gap, 8 mils or 3/8 of an inch, could be wide open. And in most cases, it creates no difference as to how much moisture comes into the cavity. Also, the depth of the plenum, which is what the rain screen cavity is, that area there. Typically, most manufacturers want us to do 25 mils or 1 inch. You can go down to 19 mils. There's some papers that even say 3/16 is better than 0. You're trying to prevent capillary reaction where the water drips on the surface, wicks in, and then kind of jumps across to the other side. But for the most part, about 1 inch is the industry standard, because that's sort of what that's, you'll find a lot of industry standards are just what we had laying around a lot of. And in metal girt industry, 1 inch metal girts are very common. So they just grabbed those suckers and slapped it up, and suddenly we have an industry standard. But it's important to have those because everybody can do it. It's not hard to source. You don't need anything unique or distinct. So it's a very, very common piece of metal, or sometimes wood, used in the vertical channel there. All righty. Something else that is you can incorporate inside rain screen is a secondary drainage plane. So typically this is like a black breathable membrane. It looks like a black sheet of paper, but it's not an air barrier. It's an air barrier, but not a vapor barrier. So it's designed to allow any moisture that makes it all the way into the insulation to still breathe back out. Your primary vapor barrier is still way, way back behind your insulation where it should be. But you can incorporate an optional breathable membrane on the outside. So what kind of gives you a second layer of defense? Is it required? Yes, no. It depends on what your detailing is, how big your joints are, whether you have closed joints where you have a piece of flashing bridging across, or open joints. If you have open joints, you got to make sure it's UV stable, or so it doesn't, and it's light shining in doesn't create an area where the UV breaks down that material from the sunlight. But essentially, it just acts as another area, another way to kind of reduce how much moisture makes it into the interior wall very efficiently. We don't have a lot of rotten walls like we used to years ago. Something else to keep in mind is rear ventilated rain screen uses ventilation. There is a rain screen system called pressure equalized cavity, or PEC, or pressure equalization. Those are a little different. They're used more in architectural metal panels. You'll see those in there. And they actually kind of compartmentalize each panel area. They don't have the kind of through ventilation all the way up the facade. And the reason for that is they use a different principle called Venturi, which is little pressure-like equalization cavities behind each panel. But if you want to learn more about that, I'll have to do another lunch and learn, or you can talk to anybody who... Sorry? All right. If you want to find out more about pressure equalized cavity, talk to a composite metal fabricator or supplier, okay? Sorry, guys, we got another thing going on here. Can we... There we go. Perfect. Thank you. All righty. So I'm going to show you some details. And if I'm going a little quick, hopefully not too bad. But if you can, I think most of you guys can read a blueprint. So this is a section cut away through the wall. This kind of dotted line here on the back side by my, right about there, right there, that wall there. That is actually where the gypsum board or exterior sheathing is. You have your vapor barrier on top of that. And this little fancy little item here is called a clip. I'll show you guys a little bit more of that later. Yeah, right there. Okay. I'll talk about that a little later. But that's basically a structural support to span the depth of the insulation. So you have this insulation cavity here. So in order to create a rear ventilated rain screen, the bottom of all wall assemblies above your through drip flashing. So you have this big long drip flashing along here. I hope you guys can see that. There'll be a little gap at the bottom of the wall panel, wall facade system, where air is allowed to go in. So this little dashed line is actually perforated, flashing with a bunch of holes in it, slotted holes typically, but it could be round ones. And that allows air to flow up and behind the facade. Okay, so it gets that ventilation behind the system. And then on top of that is your facade and whatever method used to attach it. I'll cover that later. So that's at the bottom of your wall. So this is a requirement. If you don't have a place for air to come in, air can't come out. Okay, you need a place to do it. It's not just like a dead air space. It's actually a air inlet, sort of like a chimney on a fireplace. Then at the top of your assembly, now the top is kind of subjective. There's two tops. There's a top at wherever there's a windowsill or a door header or something along those lines. Wherever there's a flashing that goes all the way through or a penetration that goes all the way through, that is technically the top of that facade. Okay, it's not the top of the building necessarily. Top of the building also includes, I'll show you detail, but this is the top of that facade assembly. So you need an exhaust place. You need a place for the air to come out. So here the air is traveling through that plenum. It reaches, this is a still flashing for a window, and air could flow around, bends around and comes, and there's a bit of an offset gap here, and then it exhausts out. So air in, air up, air out. Okay, and one continuous loop. And actually, if you go to behind a rear ventilated rain screen system on a hot day and it's like dark panels, you'll hear a little airflow, a little bit. It's quite remarkable. But that's important. So inlet, outlet, all rear ventilated rain screens, rear ventilated ones need an outlet. Okay. This is the actual top of the wall. So this is a parapet detail. Typical commercial construction. There's a flat roof over here on the right. There's a big parapet cap. They have a big parapet cap flashing, standard detailing. So you have your vented plenum here, your airspace, right, for your rear ventilation. This little dash line is, again, another perforated flashing that lets air flow through it, and it comes out just like it did at the windowsill earlier. So it gives you an idea, just some of the key basics. You do these three basics, you have a active rear ventilated rain screen. What you got to worry about is any sort of blocking or flashing or fire stopping, anything on the outside facade. Sometimes people stick things, through there. Wherever you have any sort of horizontal blockage inside the wall, right over there on the side, you got to watch for it. So we'll talk about that a little later. And here's a cross section. This is a cutaway horizontally across the building. So again, another window condition. And here are the metal bars, in this case, for the rear ventilated rain screen. That 1-inch 25 mil venting plenum space is made by these vertical strappings hat bars. The reason they're called hat bars, if you spin this around, it looks like a hat, you know. That's why they call them, as the shape of it. You'll find a lot of the construction industry, if you're not familiar with it, it's like a Z bar, C bar, D bar, hat bar. They're all the shape of that profile. So hat has a sort of two legs and a face. That's what they typically use, or we detail for our system, running vertically. And that's what creates your airspace. They're ventilated at the top and bottom. And then at the side, you can see this one has a flashing that returns to the window. Straps down the sides just to cap and make a nice clean look. There's a number of ways you can detail this, but this is fairly basic. All right, so that is the principles of rear ventilated rain screen: the airspace, the ventilation, the proper detailing, typically vertical strapping, hat bars, something like that. Now, to get there, we have to start building from the substrate out. So we got to work from the drywall, the exterior drywall, or exterior plywood, or whatever the exterior sheeting is, where that vapor barrier typically is. And typically there's that layer of insulation on the exterior, which is common with commercial. 3 inches, very standard. 4 and 5 inches becoming a lot more popular in commercial. Even 7 and 8 inches are becoming more and more common as you're starting to require higher overall effective R values. So these clips, these systems that were engineered, were to replace what used to be just a big Z profile, a big Z bar that was all the way through the insulation, really tightly spaced. You get a lot of conductive heat loss through that. So the industry is pretty much migrated to these short, little, small clips. I'll show you some pictures of that later on, with a much shallower Z bar, just a bar on the outside tip. And that reduces how much heat conducts through the insulation, either from the inside or outside. A couple standards to know. The ASHRAE 90.1, it's American Heating, Radiation, Air Conditioning. I don't know the acronym off by heart, but it was the very first standard to apply to walls, in that specifically to the substructure. So to the metal parts behind the facade, between the facade and the sheeting. ASHRAE 90.1 exists to help improve that part of the building envelope being your exterior walls, your roof, your windows, but that particular part of your wall system to reduce how much heat was being conducted through. So almost every clip made, there's about the 20 or 30 types of clips on the market, maybe more, meet ASHRAE 90.1. It wasn't a hard standard, it was the very first one, so it's not a super high one to meet. But typically what happens is you'll get a combination of metals of some sort for strength, because you got to hold, maybe 40 pounds facade, depends on what your facade is, something much lighter. So you have some sort of strong metal or fiberglass or strong material that tends to be a little bit more conductive, followed by things like thermal breaks, like that's a cork neoprene, and thermal pads on the back, insulator. These are the materials typically used to create these clips, and they're just little pieces mounted to the wall, and then the Z bar goes on top of it. They vary a lot. Your spacings will vary based on wind load, weight of your facade, and they vary quite a bit from brand to brand. So the actual effect of how well these clips work in keeping your R value high, or your conductive loss low, which is very important in this green economy, is based on your clip spacing. So if you need more clips because your clips aren't strong, they're not as effective as a stronger one further apart. Also, what you use for your thermal breaks and the locations of your thermal breaks can make a big difference. So I have 2 6-inch clips examples. So these are for 6 inches or 150 mils of insulation. One brand, clip A, happens to be our brand, at a 16 or 400 mil by 48, 1200 mil spacing. Your standard Roxol semi-rigid insulation will do about R24.6, which is 97% of what it's supposed to do, which is highly effective. Take clip B, which is similar. It's just a metal block with a big thermal break on the back. It's very popular. That type of block is very popular. That one is only 88% effective. You're in an R22 instead of R24 at the same spacing. Now, that being said, they're both meet ASHRAE. They're both very good. They're way better than what we did 30 years ago. So you'll see steps like that. So, but if you're looking at creating a high performance wall system, like really high performance, you got to really look not just at the standard, but also how they perform and what clip spacing based on your wind load for your project. So a one-story, strip mall in Calgary will have a different wind rating than a tall-story high-rise in Regina. Okay, so just keep that in mind. So here's some examples. Here's a model of it in the back right. So this is the T-clip itself, and then the little short little Z-bar, and this is it on a wall. So the blue is that barrier, vapor barrier in the background, air vapor barrier in the background. There's no insulation showing on this detail, and this is the bars. So you can see that they space out. There's the clips, clip, 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 clip. It's usually there's one clip per steel stud on the wall behind it, and on concrete there'll be different spacing. And then the Z bar that you see running across here, okay, that's this little Z bar. It doesn't go all the way through the wall. It's just short and shallow. It's a little bit modified. This is where you can kind of adjust and correct imperfections in the wall, and there is always imperfections. But that's where the insulation will end up spanning in between. So all that stuff is covered by insulation. The further apart you can go row to row, the more efficient it'll be and the less cost it'll be. So it's a win-win. All right. Then once you have those Z bars, we're going to add another layer here. And these are the vertical hat bars I was talking about. This is in this case, we're using a metal bar, and that's what creates your substructure. So between your structure, which is your steel studs or your concrete or your wood studs, your substrate, which is your gypsum board, drywall, whatever you're using on the outside, or plywood sheeting or OSB. Then you got your typically vapor barrier, subgirt, hat bar. That's what we're showing. Okay, in this image here. All right. So once we got that, we got built out. So we got the premises there. We got our vertical hat bar, which creates the rain screen plenum, the rear ventilated rain screen plenum. The next step is how do we mount it, right? There's two different ways of typically mounting the panels themselves, the rain screen panels. So I'm gonna grab a piece of material here. Here's a 8 mil fiber cement panel called Equitone Tectiva. How do I going to put it on there? We have a couple methods. You can read the slide. Face fasten, which is rivets or screws into metal hat bars or wood strapping or some other vertical hat bar system or vertical strapping system. That's fairly common. A lot of these materials are structurally strong. They're, this material itself doesn't require any frame around it, any reinforcement. It is strong on its own, dense enough, it's strong enough. It doesn't need any edge. Like you would put around a pane of glass, you might protect it if it's not thick enough. This stuff is strong and it's thick enough typically that most people don't do a frame. So you can basically face fasten it by drilling a hole through the material, centering tool, and pop a rivet in there. And that's what's called face fasten, or a screw. That's one here. The other method is where we take a facade material and on the back side, we mount a clip, okay? In this case, you can see on the right, little double leg clip. I'll show you another picture of it later. And that hangs on a rail, on a horizontal, typically aluminum rail. And that runs continuous on top of that hat bar. You can see the hat bar here in transparentish, whitish. That hat bar sits on top of that. So you still have your airspace behind it, but in this case, it's behind the rail. So your airspace goes from behind the panel in face fasten to behind the rail on blind fastened or concealed fastener. All right, so a little bit more into face fastened facades. How are we doing? Everybody good so far? Thumbs up. Anybody? I don't see any videos, so.
So far, so good.
We're good. Thumbs up. Awesome. Thank you, guys. Just want to make sure I'm not missing out on anything here. I can go on pretty quick.
So, hey, sorry, Ian.
Yes.
If I can jump in with a couple questions. The first one actually goes back to, you were talking about the 1-inch air gap.
Yes.
And that it actually came to be 1 inch mostly out of sheer convenience than really any, objective data to prove that was probably the best way to do it. I'm going to ask, is there any data or, studies or modeling that has taken place to determine what is the ideal ventilation cavity?
Yes, but you're going to find whichever expert is paid by whichever supplier will tell you whichever expert answer is right. So, but there is some scientific, processes behind that. Again, here's the challenge. You can bucket if you want to say, I got the scientific paper, but when your subtrade goes and says, no, I'm not doing that. I don't know what we're doing. And there's other factors. So remember how when I showed you that spacing here, right here, guys, remember I showed you that spacing, right? For this bars, that's based on assuming the strength of the hat bar, because you have all this wind and wind-driven rain and pressure on the exterior, negative pressure, positive pressure. So the strength of your clip, the strength of your hat bar, the strength of your Z bar that was what gives you that rigidity of your facade. And there are deflection limits. You can only let it bend so much. Some of them are pretty tight and strict. So that 1-inch hat bar has a certain amount of strength it's adding to that formula. So if you make it a 3/4 inch or a 1/2 inch hat bar, does it still have the same strength, or are you going to have to increase your number of rows? Okay, so yes, there are some assumptions the industry made, and they maybe erred on the side of caution or erred on what they had lying around, and they have tested those assemblies. But there's no there are some standards for testing that get into it, but they're not uniformly applied, because almost every building, with the exception of a very few of them in commercial, have their own little tweaks and assemblies. So nobody's gotten it 100% tested every assembly in every configuration, not even us. And we're pretty darn good at this. We have a published design guide that's national that we promote. And even us, we don't have every configuration possibly tested in a lab. Okay, right. So you'll find out. We're still the construction industry as we know it, guys. I mean, 1960s, 70s for this type of material. That's it. That's the history. It might seem like a long, long time, 50, 60 years, but in building science, it's a drop in the bucket.
Okay.
All right.
Okay. So there'd be some, like I'm thinking like, you know, the cavity you might want in, say, Vancouver climate versus, say, you know, Saskatchewan, you know, Saskatoon's climate being much drier. Is there some, is that something that should be considered and work
very good question. I'm going to cover some of these a little later on,
okay,
not one specific, but we can, I do need to get through. I will say that the brief answer to that is that cavity depth, right, is typically a minimum that the manufacturer wants, as well as it'll vary a little bit on the height of the building. So if your building is particularly tall, or if you have a long, remember how with rear ventilated, you have an inlet and outlet for ventilation spaces? If that's going to end up being really, really high up, you might want it a little deeper, right? So there's a couple little tweaks that people have done in anticipation to try to avoid future issues. Okay. That said, I could spend an hour on that alone. All right, we're gonna move along. All right, face fastened. I don't know if you guys were reading some of this in the background. We were chatting. So face fastened, in this case, this is where you're literally basically riveting or screwing the material right through into those hat bars. So it's very efficient, right? You have those hat bars up there to deal with the structure holding the weight anyways, and wind load and deflection. So why not just run a screw right through it? So that's typically what's done. Although the system that we promote is rivets, because it's harder to screw up in terms of over tightening, under tightening. That's always been an issue in the industry. It's getting better, but we find rivets, you know, they have a certain set position, or they don't break off, so it's perfect. You can usually get really thin, so 8 millimeter. So if you think about your facade on commercial, 8 millimeter or 3/8 of an inch, it's really pretty thin. There are actually even some 6 millimeter 1/4 inch facades that you can face fasten, not tons of them. But 8 millimeter tends to be where most of the industry kind of starts, and then they go thicker from there. That's not a lot of landfill in the future, right? When you look at a building and it's completely covered, 8 mils of wearable membrane or barrier on the outside is pretty efficient, right? Getting much thinner wouldn't save you tons on your footprint. So that's one nice thing about face fastened. You can go right down to 8 millimeter. Between the hat bar and the panel itself is a gasket. And the reason why we use these gaskets is the fiber cement itself has its own expansion contraction coefficient, which is almost 0. Is a cement. The steel stud behind it does have a more expansion contraction. So there's a bit of building movement and shifting from temperature changes. And we put a gasket, a rubber gasket, I'll show you guys a detail of that later, behind it to make sure that the tolerance, the tightness of the panel on the facade is at the right. It's sort of like a safety gasket, kind of make sure it's tight enough, but loose enough to still move, okay? Epdm, which is rubber for the layperson, rubberish, but it's not technically rubber. It's new generation kind of stuff. Something else called floating and fixed points. I'll show that a little later. So there's some clearance between the hole in the panel and the hole in the shaft of the fastener. So that way there's a little bit of movement and the building can shift around without binding on the fasteners and causing a racking action. Behind it, you can have that option of that breathable membrane, depending on if you go open or closed joints. You know, the only real conditions we tell people when you're mounting this is don't make sure your fixed points or floating points, which we have a design guide on. Most manufacturers will tell you how big to make their holes. There's enough clearance. And in Canada, we beef up our clearance by a couple mils compared to maybe some place where the temperature swing isn't so large. So you don't want to follow a manufacturer's instructions built for something in, let's say, you know, Southern Europe, right? Compared to Winnipeg, Edmonton, Calgary, right? The other thing is don't block vertical airflow. So whatever, if you're doing any sort of flashing across or you're going to do some sort of joint closures, the joint closures can't go all the way back and block that airspace. You don't want to have anything running horizontally across here that'll close a joint, that'll block it. That's something that happens fairly often. And then typically what happens is the panel misbehaves either color-wise or it changes shape. And we open it up and we find some guy put a horizontal block there in that airspace. So that's the only thing you got to watch for. Fixed versus floating. So on the background here, behind these insets here, sorry, I don't have the, I wasn't able to enlarge these any larger. They came as a static picture. The green spots are where the shaft for the fastener and the hole in the panel there's a lot of clearance. It's called a floating point. So the shaft, and there's a space, and there's your gasket there, and that's your hat bar. Okay, there's your two panels, your panel with a hole in it, your big head rivet that's painted the same color. So that goes all the way through. So what that does is that panel could shift around. So this steel profile can expand and contract at a slightly different rate than the panel, and it doesn't bind, doesn't crack, doesn't cause an issue. Then we have what's called fixed points. So what happens is we need to hold the panel in a certain spot. We don't want it sagging all the way to the left or all the way down. So we include, with fiber cement, what we do is we include, they drill one size a hole for each one of these points. So this hole size and this hole size are the same. But what we do is we add a little filler collar, like a big thick washer. They stick that on the shaft of the rivet and they pop it in there. And that way the weight is fixed on that point. So it keeps it from rotating. Usually there's two of these fixed points per big panels. So it holds the weight. So the rivets themselves, one rivet can hold almost every panel that we make, every manufacturer brand. The rivets are more than enough strength and shear. What we're worried about is wind load, right? Popping off, suction, wind force, all right? So that's why we have these floating versus fixed. So that's fixed fasteners. So do you have to worry about that as a detailer? No, but if you work in the installation industry, you do. If you end up working for Flynn Canada, Thermal Systems, Igloo, there's a whole range of people. If you end up working in that industry, and some of you probably will, you'll need to know about fixed and floating points. Okay, if you're working on detailing or shop drawings or running a site supervision, something like that. Okay, which is not a bad idea. You get some good experience. Face fastened facade. So this is what it looks like. So this is we called ours, we branded ours System 2. We've created multiple systems. System 2 cost us about $500,000 worth of R&D over 10 years to publish this wonderful little guide that everybody takes advantage of, which is what we want to do. Because what happens is if any of the rear ventilated rain screen products we sell fails because of poor installation, our reputation gets damaged just as much as the installers, sometimes more. So we just want to make sure it's a little bit bulletproof as possible for I said bulletproof, but I mean idiot-proof. We just want to make sure that people have everything they need to make the proper decision, even if they don't. But here's the face fasteners. You can kind of see the little shadow line. If you look at them face on, you would notice them even less. But that shows you kind of what they look like. So from 50 feet away, you would have a hard time, even me as a professional would have a hard time seeing the difference. All right, so if you want something a little fancier, you can do concealed, where they're called blind fasteners, where you don't see them blind. So the fasteners, the system that we carry is called a clip and rail. So there's the clip that's mounted in the back side of the panel. There's the rail. You usually need a little thicker material depending on what type of fastener. You can still use the 8 mil, very thin, with either a special type of mechanical anchor, like a expanding rivet called a tough fastener or turtle fastener. Or you can use an adhesive, a dynamic bond. So it's sort of a polymer type of glue, for lack of a better word. Super, super strong, works in all climates. That's another way of doing it. So you can get actually very, very thin facades, very thin veneers, if you want to call it. And all that would really vary is how many clips you have on the back. Still the same thing, though. You need that vertical air channel behind it to give that space, okay? Same rules as everything else, right? Open joints, closed joints. You can don't block the airflow. So again, just because you have a rail here doesn't mean that that's your airspace. Your airspace is actually behind it. So you don't want to put anything between, no membranes between this rail and this hat bar. Okay, you put the membranes, the breathable membrane behind the hat bar every time. Okay, whenever you do rain screen, any membranes are behind the bar, the plenum space, usually right in front of the installation. So here's a detail. This is section on the left. Here's a photo of just the outer layer of that. So this is the hat bar here. This is the hat bar here. Okay, and there's your rail. Here's your rail. There's your clip. Here's your clip. In this case, we're showing a dynamic bond. So this is a think of it like a sticky tape, top and bottom, and then the adhesive is applied and it squishes out and creates a really, really strong bond. There's some information on our website if you guys like that, but that gives you an idea what she looks like. Okay. They hook on, they tap, they drop a screw on the top of one of these clips at the very top to do a fixed point, just like they do with the rivets where they do that collar. On concealed fasteners, all the rails and clips are all hanging, and they can move independently, but one point on one corner of one clip has a mechanical or bonded connection to the horizontal rail, so that way the panel again does a slide left or right. Can't fall down, can't lift up. Typically, the legs are too long for that. But that's what you see. So this is what she looks like. This is actually a Tim Hortons. Tim Hortons did a fair amount of concealed fastener with our fiber cements. A lot of places in Canada. 8mm joints, bear claw rails, and this is Equitone fiber cement. They could have put a better joint here on the side. You can see it's a little tight there. That's my only criticism, but that's what a pro would look like. Most people think tight's fine. Tight just means you're missing a little clearance. You can put a little bit more room there, especially because this is metal. It's going to move around quite a bit. All right, moving on, standards. So when you're dealing with facades, with the outer layer of a commercial building, residential doesn't have as many strict standards either. But in commercial, you're dealing with non-combustible, combustible. You're also dealing with sort of quality standards, like how well does my product stand up to rain or frost or any of those types of conditions. So these are lunch and learns on their own. These are long topics. I can't do it justice here. But the ones you can look at for rear ventilated, there's two large industries. The one in particular for quality of materials is called European Standards, or EN, or European Norm. As they imply, they're a European standard, and these are where most of these products grew up. Most of the products manufactured for rear ventilated rain screen are European made. Belgium, Germany, Spain, you name it, UK. So the European industry is way more evolved than the Canadian or even the American one. And because of that, they've been doing this since the mid 1800s, guys. We've been, maybe 1960s, I was saying. So, they've created a battery of standards of tests that you can use to compare apples to apples for quality. So if you end up in spec writing, I encourage people to just borrow the European norms until Canadians and Americans get our act together and get our own norms. Because right now what we do is we grab norms as standards that are close, but not the same material and not as a facade. And we try to make everything about density or everything about one particular aspect, which your product happens to have the best number on, and then you convince the architect to don't allow anything else. So European norms are a little bit broader, more industry-based. American standards, there are a few, but they're not specific to facades too much. We don't find a lot of them. UL is probably the only one that's kind of close, but we have our own ULC, Underwriter Laboratories Canada, C. The other ones are decent. If you've got nothing else, if you can't find an EN standard, try to find an American standard, something closely related. Okay. And again, that's just establishing quality. So if you're trying to compare brands to brands in the future, those ones are there. But there's no legislation in Canada. There's no national building code that you have to meet a certain EN standard or ASTM standard. They're usually project specific, written in by the spec writer, architect, or that firm based on their experience. Okay. Canadian fire standards are a law, though. You have to meet these, otherwise you're in big trouble. In commercial construction, this is all for commercial. There are three basic fire compatibility tests that apply to facades. The first one is your product combustible or non-combustible? And then there's an alternative test for, yes, I have a combustible product, but it's not that combustible. You'll find that a lot of standards are about selling exceptions, guys. Make a rule and then sell the exceptions. Time-honored government tradition. S114 is the test in Canada to determine if your product's combustible or non-combustible. It's an oven test, so you have a certain thickness of sample, you stick it in there, you bake it, you see how much it degrades and how much heat it generates. And if it doesn't, if it meets the standards, you're considered non-combustible. Concrete products, that kind of stuff, typically, steel products typically have no trouble with this test. It is a pretty strict test globally. The Canadian test is pretty strict, so keep that in mind. So if you find somebody who says, well, my test standard in, America, my E84, it's not the same as S114. And more importantly, it has to be tested to Canadian standards to be used on non-combustible wall assembly. The second standard is S134. It's basically the same as 114, but the difference is with the 114, your sample size has to be so thick. And in facades, some manufacturers can't make it any thicker. Like they can only go so thick with their equipment, so they can't meet the test standards. And you're not allowed to stack or laminate them to create the test sample for the other standards. So they created an alternative standard, which is basically what you see on the right. They basically torched the surface. Instead of putting it in an oven, they applied a cone calorimeter test, which is basically blow torching the surface and seeing how much it burns through, if it supports a flame, and if it still burns afterward you heat it up. So 114 and 135 are the non-combustible or limited combustible. Basically, those are suitable for almost every project. High-rise buildings typically have allowances for some materials that are combustible, provided they meet the third test, which is S134. So if you're not going to pass 114 or 135 as a product, if you're looking at products, so they won't pass those two. You can look at 134 if your project requires it. And this is an exception. So what they do is they do a window opening, and they stick this facade material at the window opening, and they try to light it on fire and see what happens. They light a fire on the inside of the window, and they see how fast it spreads, and they see how fast the heat, how much heat it generates above the opening, and how fast the flame spreads. All right, so I don't want to spend too much time on that, but those are the three critical ones. So let's get into the fun parts, okay? Facade material options. So now that you know how to put it on the wall, you know how to detail it to get it on your wall properly, decide between face fastener and fixed fastener and blind fastener. You've met the Canadian standards. What materials can I start playing with? So let's look into those. Fiber cement. This is a sample I've been playing around with quite a bit. This one here, very, very popular. It's been around since the 1800s. One of the very first ones in the world, like I said, 1805. A company called Ethernet, which has now been rebranded to Equitone, is produced basically a really durable cement, but very thin cement material used for roofing and now wall systems. FRC is the acronym, so fiber reinforced cement. It's sand cement. The reinforcement is wood synthetic fibers, so wood pulp basically, because wood's actually very strong. And then water, and it's basically that's it. That's the ingredients, maybe a couple additives here and there for the modern world. Things to help it cure better and that kind of stuff. I'll talk about how they're made. Equitone has its own particular way of being made. There's a few out there like it, but it's not like you take the cement slurry and like you pour it into a mold. There are systems that have that option where you just you mix the cement and you pour it into a cast and let it harden. Those tend to be glass reinforced fiber cements, so GFRCs. But the one that Equitone uses is a lot different. I'll show it to you in a second. The ones made in Europe have 10-year warranties, and they have this EN 12467 standard that I talked about earlier. So there's a really great industry standard for comparing product line to product line. 135 testing that you needed, and it's about 3 pounds a square foot, which is really light. Some fiber cements are 8-12 pounds a square foot. That's important when you guys are picking it up, installing it. So this is how this product's made. So these little vats here on the right, these are big drum rollers, and in that is that sand, fiber, water slurry. So a big pool of fiber cement, basically, uncured. And then what happens is this conveyor belt system has a felt on it, and it slowly picks up layer and layer and layer, and it builds up this thicker and thicker layer on this conveyor belt system, and it deposits it onto this really large drum. All right, so this is that layer, that conveyor layer system. So you can see the fiber cement slurry slowly thickening and thickening, And then what they do is they build it on, they transfer that layer onto these big, large rollers, these huge rollers. And then after that, they take that roller, they slide it, they slit it, and they slide it onto a tray, and bingo, bango, you got a sheet, right? So he slits it, it rolls off this way, lays into a sheet format, they press it, squeeze the extra water out, make it higher density. And that is Equitone, and others like it. So what you get with these types of natural products is you get these natural variations in color. So it's painted products or printed products where they print on the material. Have a really hard time creating this. They tend to do, you know, it's hard to get very distinct images or real natural variations. So fiber cements have very subtle variations in hue, texture, color. It's even gloss on some surfaces, and it creates sort of like that faded blue jean or that very fiber cementish look, but still uniform within its range, but a little bit of variety. So this is a fairly flat elevation with a lot of different depths in it, right? They can also produce a very, very solid color. They can create a very uniform, smooth texture using the same process, a little different on the end product, but they create this really nice, uniform, you know, dark grays, browns, greens, all that kind of stuff using fiber cement. They can also machine it in the shop to create these grooves. So these are grooves into the material, and face fastened here, and you can kind of pick it up. So those are some of the Equitone lines that make fiber cement. Let's see, we're getting low on time, so I'm going to speed up a bit. Okay. Another product you can use is Phenolics, or that's what we use in North America. If you look up online, you might see HPL or high pressure laminates. These are basic. I'll show you guys how that looks in a second, but they're made from various layers of craft paper. So they take sheets of craft paper, which is basically wood pulp paper, and they layer together, and the phenolic part is a resin. It's sort of like a glue, and they slur, they get everything soaked into this thing, and they put it into a press, and they squeeze the life out of it. High pressure and a little bit of temperature, and it bakes into sort of this plasticized monolithic laminate. Very, very durable. And in that process, they can actually add color to the outside and inside layers, you know, whether it's a print, like a wood decor, or a solid color. They vary in thickness from 8 to 10 to 13. The ones made in Europe have a 10-year warranty. They have very large sheet sizes. They can go up to, you know, 3.6 meters, 4.2 meters, you know, 13, 14 feet, and usually from 4 feet or 1,200 to 5 or 6 feet in width. They also have an EN standard for Phenolics, or HPLs. It's 438, where they test a whole bunch of things. And these are combustible. That's the trick. These ones will not work in complete non-combustibility. They require the M134 testing if you're allowed. Also very light, 2.2 pounds a square foot at 8 mil. So what they do on the outside layer will vary a little bit. So they can either have an outside layer of craft paper that's printed with a solid ink, and then a clear coat on top of it, a protective laminate color on top of it, and that gives you your color, right? Your reds, your blues, your oranges. So it's not like paint deposited on the surface, paint deposited on the craft paper, pressed with the protective layer on top of it. Another product, Parklex, really beautiful product. They actually use a real wood veneer. So they create the phenolic core first. They do that squish and do the phenolic core, and then they veneer a wood veneer and then clear coat it on top of it. Gorgeous natural wood. So another option. So either fake wood printed or real wood. And there's a price difference between the two of them, obviously. There's a limited range as to your wood ones. It's more expensive, but it's certainly more attractive. So this is a printed one. This is Formica. This is a wood veneer. In this case, it's a segmented. So that means it's a curve, but the panels are actually flat. But the rails, you know, have each little rail joint has a slight angle change. And the face fastened, you can barely pick it up. Some of you might be able to once you see the presentation later. This is Parklex. This is a wood veneer. So they're all very distinct panels. And this, yeah, usually the grain direction goes in a long way. This way they ran it the vertical. So that's something else you got to keep in mind when you do facades, is what grain direction are they printed in. Here's Parklex again, but with a perforated for acoustic. So you'll find a lot of times people like to do the design of, you'll have your exterior candy, your beautiful entrance, your entryway into your beautiful building, and it's covered with these nice, beautiful rear ventilated rainscaping products. And then they'll carry this into the lobby area. And because they're hard surfaces, you're worried about echo. So you can perforate most of these things and create a nice nifty way of absorbing sound while still having the same look as what you had on the outside. This is probably the more common way people do park lights. They do a whole bunch of less expensive material around it. All this is a composite metal panel, not something we sell, but very, very common. And then they use the park lights right at eye level where it's pretty and sort of, you can see it. So this is very, very common, and use as much of the sheet as possible. Less waste is better when the material's more expensive, which park lights is. Gentas is another brand that we carry. Large sheet sizes. You can see how long these ones here are, elevation, large dimensions. Really beautiful, durable stuff. Probably very, very popular in schools or any place where you're worried about UV loss as far as color. Phenolics have excellent, excellent UV resistance as far as fading. They're also tough. They can take a beating. Like very few products can. It can still scratch. Almost everything can still scratch, guys. But this will give you an idea what you can do up to that point. Something else you can do, and that's in the future. You're going to see Formica has done some of it through their Vivix line. A few other guys have done it as well. You can actually create custom prints. So before they squish that into a panel, instead of doing a wood decor, they can literally paint, digitize an image of the woods, and each individual panel will have a distinct look to it. I've done a couple myself. They're really, really remarkable. I've done paintings. I've done native decor, and you can create this sort of think of it like a wallpaper concept, but on exterior panels that meet all the exterior UV and warranty stuff that you need. So when you create an image on the outside, you certainly can. Another material is Terra Cotta. Here, let me grab this on my arm on the camera. This is Terracott Clay tile. Okay, Terracotta clay ceramic. When you heat it up and cook it, it's called ceramic. You fire it. Made from natural clays. Basically, it's clay with a bit of additives to make it, moldable. On this one, you can kind of see the two different tones in the groove. So they'll use the expensive clay on the outside, a little cheaper, stronger clay on the inside core. Clay is an organic product. It has different strength characteristics, so they'll vary a little bit. But they extrude it, which is basically take a big Play-Doh machine and squeeze it through a die being a cutout plate, metal plate typically. And then that's what gives your profile that you can hook onto the rail system. So slightly different detailing, but very still rain screen system. They typically vary from 26 to thicker. Like I said, you don't use a hat bar, you use kind of a hook channel bar, which is similar. Again, out of Europe, they're 10 years, almost all of them are made in Europe. And the tiles can be 6 by 6 up to, let's say 2 feet by 5 feet long. Depending on the manufacturer brand, ours can go up to 2 meters long, actually, 600 by 2 meters. They have an EN 436 standard. This is for frost resistance. It's a little more less limited testing. And they're non-combustible S114, and they're relatively light, 5.6 pounds per square foot, relatively light. So here's some examples of it as a wall facade as well as a screen. So a lot of people use the Play-Doh aspect of it to create these square, what's called baguettes or sunshades, and they mount it over metal, they slide metal rods inside of it or behind it and create this really beautiful over curtain wall glazing glass window architectural effect. In Europe, we don't do this here, but it's non-combustible. There's no reason you couldn't clad it as a roof, one continuous one. So this is remarkable. You can actually see the bottom right beside my shoulder here, or up right here, right there, where my thumb is. You can see they're not quite done yet. You still see the channels. You can also glaze, so you can take it as a natural sort of clay color, or you can actually do a glaze like you do with your coffee mugs. I don't have one with me today. Glaze, which is a tinted, pigmented glass, hard coating on it, and create these beautiful glazed colors. High gloss, very durable, resistant. And a couple more. Porcelain, which is the same tiles that you guys see on flooring. You can actually do large format porcelains. They're 6 mil. What we don't do is we don't do face fasten with porcelain, so we always do concealed fastener, and we use the bonded method. Large format, so 5 feet by 10 feet, 3 meters. They don't have the EN standards. They have a couple different ones because, again, they're a little different market. They're non-combustible, and they're also very light, very durable in impact, very, very durable. These things are tough. We use it for flooring. We know it's tough. So Nordstrom is one of the brands that use it. There's a concealed fastener. There's another one there. A lot of times you can't even pick up the subtle veining. They do a lot of Calcutta looks, a lot of marbling looks. And then slate. So slate is exactly what you think it is. It's natural slate, hand split, no chemicals, no water. So literally the big trucks chop up the slate in the quarry. They bring it over to a factory where they chop it in smaller blocks. The guy splits it by hand, sends it through a machine to mill it to the dimensions of the system, and it goes into a box, and it's off to you. So as far as green products, slate is, and there's tons of supply in the world. Slate's quite a remarkable product. So Coupa is an excellent product. I actually just sold my very first one. It's a new product line. We've only had it for a couple of years. I sold my first house in Calgary, a small little Coupa slate where people are wanting something else besides brick. They have hidden or exposed fasteners, again, 10-year warranty, lots of variety in sizes. They have both industry fire testing, depending on which one you want, because, again, the thickness. And they're a little bit heavier, but not much, depending on the tiles themselves vary in thickness. Like even when they're hand split, they might be a mil bigger or smaller. Okay. So that's why the variation in weight. But that's what she looks like as a facade. This is beautiful stuff. Something else, something I would sell to a residential contractor, because it installs more similarly to, it still has a rain screen bar system behind it, but it's simpler to install than some of the other ones because it's pretty forgiving as far as if your plywood or your sheeting is a little off tolerance. Okay. So I'll just wrap up a couple things and I'll grab some questions. So engineering assemblies, we were always trying to get the contractors and the architects united, design the house of design with the field of construction. So we created these publications where architects and sub-trades are working from the same Bible, to use the acronym, right? So we standardized everything. In our design guides, the very, very back, there are these little engineering stamps. You can kind of see it where my finger is, right there. So we've actually created pre-engineered systems. So if anybody just wants to follow our design guide instead of re-engineer themselves, they can. It's non-proprietary, so everything that works for my fiber cement works for pretty much every fiber cement. It includes all the adjustments for Canadian climates, like our gaskets in particularly, and our fixed and floating points. It's regularly updated and republished, and we sell all the subframe components. So one of the things that's important when you're selling or you're promoting a system, any system, is that not one competitor locked the other competitor out as far as, if you don't buy my system, you can't use my components, so therefore you have to redesign everything. So we've actually stocked all the materials behind it, all the substructure components, so people can use it. Something else. Don't become expert. If you're not an expert in an area, don't pretend you are one. My job is to educate architects and consultants. They're the ones who are the experts in the construction of a building. I am not. I'm the expert in my little part of the pie. I always support my sub-trades. They're the experts in how to install it. They're the guys who do the installations. I don't. And owners, we always try to make sure that they understand the pros and cons properly, so that way they're getting what they actually buy. The industry has a lot of work to do as far as standardizing systems or getting our specifications consistent. Specifications are what people write to ensure the quality of a product. So, we've hired full-time consultants. We're hoping more industries do the same. And like I said, just don't, if you're looking for information, make sure that you talk to suppliers for anything like finishes, test standards, that kind of thing. Contractors when it comes to install rates and schedules. How long does it take to install this, for example? Guys like me may not know the market, that particular market. And then regulators. If you're not sure, talk to your regulator. Pick up the call. Any Joe Blow can do it. You don't have to be an expert. You call up a building code expert and say, guys, what's going on here, right? Can I do this or can I do that? Or talk to instructors if you already have one. They're experts in this industry. So I'm going to leave this up while in the background. I'm going to change myself off here, but I know that some of you guys might have to go. It's already 5 o'clock, but I'll hang around and answer questions, and we'll go from there. All right. Thank you, everyone.
Thank you very much, Ian. Really, really appreciate that. I think a lot of what you mentioned, especially some of the substructure, makes a lot more sense in my head now that I see it and you went through your presentation, so thank you. We got one question here in the chat from Patricia. Is your design guide available online for the public?
Very good question, Patricia. Yes, absolutely. It's available on our design guide. Just go to engineeredassemblies.com. So it's our company name, engineeredassemblies.com, and look under design guides or guides or systems, and it's called the S2 Design Guide. It'll ask you to fill in your information just for, we're trying to keep everybody up to date when there's an update or there's something major to change, but plunk it in there and it's free. And if you can't find it, look up my contact information on the website and send me an email and I'll send it to you. And it just reminds me, I gotta add my email to the slide. Sorry guys, I missed it. I'll add it here while we're talking. What's the next question?
Let's see here. We've got Darren, our instructor, asking, does facade material testing include the clips? If not, what is covering the clips?
The facade material testing? No. So typically the material, the facade systems, the testing, the EN standards are just the material itself. So they kind of isolate the testing for EN standards to how does that piece of whatever it is behave as a facade. So those EN standards are like, how does it behave when it gets wet and dry? How does it behave against hail? How does it behave against a UV? How does it change in color? What's the strength characteristics against this sort of impact testing? So it's really limited to that. There are some assembly tests available out there where you have different configurations of, okay, how does it work as a wall system for keeping water out or along those lines? Those are ASTM tests. So, sorry, AMA tests, AMA tests. There's one in specific for rear ventilated rain screen, which is AMA 508. So AMA 508. So there's a test standard where you have you try your wall configuration and you run it through a test, and it has sort of it gives you test results, and then you can use that to compare other people against the same objective test. What you're going to find though is not a lot of people have their AMA 50. I said 508. It's supposed to be 509. If I mispronounced it, it's supposed to be AMA 509 for rear ventilated. There is a 508 test, but 509 is the one we're talking about. But you got to watch for it. And the reason for that is, like I mentioned, almost every architect has their own build a better mousetrap assembly. So they might use a Z bar, hat bar, and then this and this and this and this. All the configurations haven't been tested. So a lot of people wait till there's a project that demands it before they actually go through the testing system, because it's a fairly expensive test. So you can imagine spending 20 grand Canadian per test. Plus and that's just a test cost, not including getting everything, setting everything up, all the, on the material costs. And that's only good for one assembly and one system and one product. Okay.
I was thinking actually more like the fire testing, like is anything governing like some of these fiberglass clips versus the metal ones you guys are using?
No, there is, that's a very good question. So whoever's asking that might have dealt with City of Calgary once or twice.
That's Darren again.
Okay.
And yes, I have dealt with them a lot.
Okay, it's a fair question. So when I talked about what do your local reps allow, what do your local inspectors, that was exactly what that point was, particularly fire test. You want to ask, you want to know what the local guys think is true or false. And as far as what consists of the wall. So in fire testing in particular, you got to watch that there are exceptions, and a lot of them. Aluminum gets a general exception as a non-combustible material, whether it would pass S114 or not. That's a great example. Try to get any aluminum company, curtain wall company, show me your S114 testing. They're all going to say, we don't need to. We're exempted. We're exempted because we're aluminum. Aluminum's melting point is well below the S114 testing. Aluminum is a pile, except for maybe some specific high-end alloys, which nobody uses. You're not gonna pass 114 with a block of aluminum. That said, has it been a big risk? Have we seen a lot of failures? No, not necessarily. So when it comes to things like City of Calgary, there are exceptions for thin enough material. Like coatings on products are considered, I can't remember what's the word. Minor combustible. I think that's the word. Don't quote me on it. You can research it. And I do have a little white paper I wrote as an internal memo. If anybody needs it, I can send it to you, sort of my research, but don't cite me as a source because I'm not an expert. I never will be on fire, just a relatively well-educated guy who makes good guesses. So along those lines, there are some things that are thin enough that you can ignore for testing. Membranes, for example, typically sometimes get exempted. But when it comes to like clips inside the wall assembly, right? what, if it's fiberglass versus aluminum versus steel, how does it behave once it's sandwiched around Roxol semi-rigid insulation compared to polyiso, compared to polyurethane, compared to polystyrene, right? The industry is still working on that. So what cities have done is pretty much created their own bylaws, mandates, and you've got to follow those. Their inspectors are gods in that realm, and because there's not a lot of other things they can rely on. So you can fight it, and if you have good enough evidence and you want to help do the legwork, I think more power to you. I think the industry has to work on that, but I would rather you just work on compliance until and because ultimately the risk is up to the city. They're the ones who get sued if things get screwed up. And they, in turn, sue everybody else.
Okay, thank you.
Any other questions?
We've got another question from Blake Early here, Ian. He's asking, what is the typical cost range per foot or meter of the system? How long does a typical system last in terms of life cycle?
Oh, excellent question. So, I can't give you really hard, specific answers. I got my email up now. Sorry, guys, if I forgot about it. So, igruber@engineeredassemblies.com. That's our website, obviously. But to answer your question, installation. So, because you're typically dealing with these rear ventilated rain screen products, they require that ventilation in addition to the rain screen. Things like Phenolics and fiber cements don't age very well unless the humidity on the back side and the front side of the panels are the same. The reason I'm bringing that up is because they require a certain amount of materials and design that kind of create a fixed cost to it. So whether you're doing phenolic panels, fiber cement panels, Terra Cotta panels, there's not a lot of variation in the installed price in the end outside of just the actual cost of the facade material itself, but everything else behind it, all the structure, insulation, membranes. So when you get a price in commercial construction, typically you're getting a price from an installer who buys the material from us, but he takes it, he marks it up a little bit, typically, and then he prices all the bars, half bars, clips, membranes, everything, insulation, because they're responsible for all that scope. So everything off the drywall or the plywood or the OSB board, that's what they're building. So that in commercial construction for rear ventilated rain screen systems, you're probably starting in the mid 40s, regardless, $40 a square foot or 400 square meter, roughly, just to get in the ballpark. Okay. Then after that, it's okay. Well, what's the cost of the materials you can add to that? So a fiber cement might add $12, $14 a square foot as a system. That's the bars, the gaskets, the rivets, the materials. You can also go to like Parklex, which will add 20 to 25, or concealed fastener systems versus exposed fastener systems, about an $8 to $12 price range difference. So yeah, low end, you're probably looking at the mid 45s, 50s, and today's market Canadian dollar installed with insulation barrier membrane to, you're getting close to the hundreds, probably mid 80s, 90s, realistically with most of the systems. You can probably peak at 110, 120. And this is all assuming it's fairly square material and a fairly flat wall. As soon as you introduce triangular shapes or irregular shapes, you're going to end up in the high 80s if you're lucky. So, and that's again just labor. There's a $2 or $3 cost a square foot just to cut the stuff, right? Right. So it varies. So to give you a comparison, I've been told that you can install a brick for what, $30, $40 a square foot in a comparative, and that's just brick and that's finished. Versus let's say Equitone Tectiva product, I'd say if somebody was going something fairly basic. And the only reason I'm giving you guys install rates is because I work for an installer for 6 years. So I have some experience in it, and I can make a wild ass guess and not be totally wrong. But I'm always wrong based on design. Until I see your design, I'm always wrong. So let's say $30 for this, $30 for that. You're probably starting around $60 a square foot. If you're in the $60 a square foot for your exterior building envelope components, if you have a budget for that, you can play around with a lot of fiber cement or phenolic or materials. If you're lower than that, you're looking at brick EFIS. And if you're lower than that, you're looking at folded metal of some kind. And if you're below that, good luck. That answer your question?
Perfect. So it looks like that was the last question in the chat.
Yeah, I can confirm Slate has Terra Cotta. Sorry to jump in. Slate has Terra Cotta, not my Terra Cotta. My Terra Cotta, if you end up at Stantec downtown Edmonton, that's my Terra Cotta. That's and a new building is coming up right away, the Ice District Tower. So that's that one. But Slate has Moting, which is a German-made one distributed by Thermal Systems. Yeah. Sorry to jump in. Go ahead there, Jose.
No problem. I was just wrapping things up. Looks like there's no more questions in the chat, and we're 11 minutes past. So I wanted to thank you, Ian, for taking the time to chat with us today, especially at the end of a Monday. I know that could be tough sometimes, so really appreciate it. And thanks for everybody for coming out. This will be recorded, so if you just want to go over to Microsoft Teams, there's a team within there called ATSA Lunch and Learns. This recording will be uploaded to there. And thank you once again, Ian.
My pleasure. Thank you, everyone. Like I said, LinkedIn, look me up. I'm Ian Gruber, not hard to find. And we'll see you around. Good luck in your careers.
Thanks. Take care.